Hello everyone. How's everyone doing so far? I hope that you're enjoying your time at 90 Days of DevOps. So, I'm Rinaldi, and today I'll be talking about seeding infrastructures, merging Terraform with generative AI for effortless DevOps gardens. So, let's just get straight into it. So, a bit about myself. I'm currently working as a software engineer at Seek. I'm based in Melbourne, Australia, and I currently hold all 13 certifications from AWS. I also am a subject matter expert for the AWS Lush's Architect Professional and AWS Data Analytics Specialty Certification. I have been an international speaker at 40 plus events and conferences. So I talk about a lot of different things, mostly technical stuff related to cloud-based stuff, such as within AWS, but in general, I spread into a lot of different topics too, such as project management as well. Aside from that, I really enjoy all things AWS, open source, and virtual reality. So, just a bit of introduction to our topic for today. Let's firstly look into what generative AI within Terraform looks like. So, generative AI, as I'm sure that most of you probably already know by now, is quite a popular term to be used and thrown around. It has been adapted by a lot of different people in different contexts, whether it be in their personal lives or whether it be in industrial context. It's no stranger to anyone at this point. Within Terraform, it has the ability to create Terraform scripts by just providing requirements. This is because of generative AI's use case of code generation. So if you recall your favorite generative AI models, for example, maybe those based in Amazon Bedrock such as Claude or OpenAI's models such as ChatGPT, then it won't be such a stranger to you because it has the capability of being able to generate scripts with ease and quickly too. So this saves a lot of time and allows you to automate the process while allowing you to then manually do just some small tweaks to the code to make sure it actually works properly according to what you need it to do. So it can perform instructions step by step because of this too. So you can specifically say, all right, can you first do this, then after that you do that, or there are also many open source projects right now that are trying to make GPT, for example, move on its own, such as AutoGPT, which is trying to make a way of how these sorts of prompting can go on to then create another prompt based on the result. So there are a lot of ways of how we can automate these processes. Of course, in the AWS ecosystem as well, for example, you can create step functions, for example, that build upon your results and further prompt accordingly to refine your results. So that's just some ways of automating this. And what we really want to be able to get out of this is create a symphony of code, human and infrastructure, because we want humans to be able to work with these AI, and we also want the code to be able to work with infrastructure alongside humans as well, of course. So creating a symphony is a very important thing, and certainly is the key moving forward to be able to create robust and easy deployments while being able to ensure that they're of high accuracy. And this brings us to the potential of a seeding engine. So what is the seeding engine in this case? It's really an innovative approach of being able to craft and optimize your Terraform scripts. So the standard deployment would be if you, for example, had a Amazon Bedrock user interface open and you particularly just submitted a prompt that says, can you generate me something based on these requirements? But what if we can take that a step further and start looking into how we can automate the whole process and try to bring it forward as much as we can to have it cover not only the code generation, but also assist with proactive management of whatever happens with our sites, for example. That is the goal of being able to create these seeding engines, and what is a lot of people are looking forward to at the moment, because that's the end goal of AI, to be able to ensure that we can easily manage these kinds of systems with much more ease. We can also grow infrastructures further by having generative AI analyze requirements and adjust infrastructures accordingly. So with this, there's really a lot of potential that it can do in sustaining our systems. Aside from that, these kinds of seeding engines are also able to consider best practice within security and scalability. So this might be based on the general knowledge base it already has, or it could be, for example, retrieval augmented generation trained. So we put our own guardrails, we put our own data for it to take from, and accordingly consider those best practices. And this will overall lead to a minimization of code churn for DevOps professionals, hence making our jobs in general that much easier. So we're going to talk about one such implementation of a seeding engine that I've created in this case scenario. So just a quick caveat, there are a number of different architectures that are possible to be made out of these kinds of seeding engines. This is only one of them. This is based on a simple implementation that I've made. And keep in mind that this architecture is a simplified version of the actual architecture. So in the actual architecture, it is much more complex. There's going to be more moving parts. There's going to be more services that's used. Like, for example, I didn't really mention about IAMs here, but regardless, this is a good abstraction of the key components of a particular architecture. So the seeding engine itself is hosted on EC2. So that's where we're going to host our program, where we're going to run it. And accordingly, we want most of our templates to be stored on S3, and for metadata to be fetched from DynamoDB. So all credentials that are necessary as part of this process, whether it be, for example, Bedrock calls or anything else, will be obtained from Secrets Manager to be able to obtain necessary API keys. So we're using Bedrock in this case for our generative AI service. We're going to be using the Claude V2 model. So that's where we're going to create the generative element of this. And we will also deploy our code and accordingly execute the CI/CD pipeline going through code build and going to AWS code pipeline from there. Notice that we also have a few Lambda functions too. So Lambda functions in this case scenario is meant to be more of a proactive measure. So when a template changes to S3, for example, it accordingly sends it through to code build to build the code. And similarly with CloudWatch, it's integrated with CloudWatch 2 to be able to proactively send through warnings or remediations to EC2 if CloudWatch detects any anomalies or any threats that happen to come across. So it helps to proactively manage this way while also being able to communicate with the EC2 to manage these findings. Prompting itself is an art, I would say, in this case scenario. So if you've already played around with generative AI for a while, it shouldn't be a surprise to you that prompt engineering is one of the most important things within these kinds of projects. So there are many ways that you can prompt engineer for this kind of deployment. So I chose the path of a more complex and detailed way of saying things. So in this case scenario, for example, I already know what services specifically that I want to get out of it. So you can definitely say other things as well. For example, like, I want to build an Apple application. Can you recommend me the necessary EC2 instances and deploy them accordingly. So that's one way of saying it, but I already have a set of requirements in my head. So what I did was that I mentioned specifically each of the services that are used here and just mention everything that needs to be created as part of this. So we can see that I'm just saying create a Terraform script for deploying a scalable web application on AWS. The setup should involve the following components. And in this case, as you can see, I just had included some EC2 instances, auto scaling group for the EC2 instance to handle the different load variations that might be possible. Accordingly, provisioning ELB, using RDS for the relation database service, having an S3 bucket, having an AWS IAM run policy, and accordingly setting up a VPC and some configuration too. So keep in mind that this is not the exhaustive list of what I am trying to do. So it's pretty simple. You can pretty much just replace some stuff accordingly with what you need to. You can just replace RDS, for example, with DynamoDB, which is what I'm using as well currently. So it's pretty simple stuff, and it's really your approach to experiment with what works for you, whether it be the simpler queries that are more paragraph based and just say, all right, I'm trying to make this. Can you suggest me recommendations? And accordingly, you can tweak the configurations from there and the services involved there too. Or you could already come in with this specific service that you have in mind. So it's really different ways of being able to do this. And at the end of the day, you still need to tailor it yourself by reviewing what is created and accordingly tweaking it. So you still need to continually work with the AI to make sure that the output is what you require. So let's take a look into a bit of the code. So again, keep in mind that this is not an exhaustive look into the code. This is a very high level look into the code. So it's not a very detailed one. And this is to get you an understanding of how it would operate on a high level. So in this case, we're declaring a class in Python called seeding engine. We're just initializing it and pointing Terraform to the appropriate working directory. We then have a generate Terraform script function, which accordingly we invoke based on the scenario that we have out of it. And we also have one for deploying the script itself, which we basically just do a file write and basically just execute Terraform init and Terraform apply accordingly. So, and aside from this, we can see that we are just executing the seeding engine. We are running the script and deploying the script accordingly. So this really is a simplistic version of it. The version that I currently have in production is quite different because, well, it's meant to be more step-by-step and is much more dependent on certain steps to be approved before other steps because, well, that's how you need it to be in production environments. You need it to be grown in that sense. But in this case, because we want to look at a foundational version of a seeding engine, that's why I am putting it at a simplistic version. So we can then look at how we choose to make the bedrock invocations. So we can see that we are having a request body, we're declaring the parameters there, and we're just setting the max tokens to sample to the maximum amount, and pretty much just accordingly declaring the temperature and top P. We're putting it at a very conservative value because we want it to be more based on facts and not have it hallucinate, because it's code based after all. We want to make sure that we can reduce the work that we need to do based on what we're currently getting out of it. So we can see then that we are declaring the model ID as Anthropic Cloud v2. We're declaring the accept and content type accordingly as application/JSON. And we're then invoking the model using Bedrock runtime and getting the response by loading it via JSON and reading it, and accordingly printing it out so we can see how it looks like before we then execute it. And this is an example of what one sample output might look like. So we can see how it is able to generate an appropriate Terraform code based on our requirements. So keep in mind that this is just an excerpt of the code. This is not the full code generated. The full code is much, much longer than this, as you can imagine, by how many resources that we asked to be created. So this is just a demonstration of how it's able to do this. And what we can do then in a production environment is that we can start to put through more steps. We can do this, for example, within a step function that shows what we need to do once the output is here. So we could then validate it. We can then run test cases to see if this still appropriately matches what we need. So this is just a showcase of how we would have it put out, and we can then start putting steps afterwards to build upon this output and validate, put feedback, and refine it accordingly. And speaking about feedback, it's important to also understand how you can continually test and create a feedback loop so that what you do will continuously be tested for accuracy and ensure that it is performing as expected. So we need to be able to understand how users are utilizing the engine first and foremost, because we need to be able to get them to put the proper prompts, and if not, then we need to understand how we can facilitate their experience better for them. Aside from that, we also need to ensure that we understand prompt engineering very well so that we can provide and get better responses from the generative AI that we use. Within an organizational context, we need to ensure that we provide a proper feedback loop. So within these kinds of projects, it's very important that we have a consistent feedback loop that takes place. And this needs to take place across the organization. So we need to collect different feedback based on different requirements from different people. So there could be data analysts and solutions architects. They all might have a different perception towards how these kinds of things are generated. And it's not only related to Terraform, it might be related to other infrastructure-based setups that they will be dealing with. So these kinds of things are very important to tackle, and having a transparent feedback loop is very important. You also will need to continually have it refine responses as needed too. So if the response is not proper, you need to consider how you will go about refining it. So oftentimes, and if you've played with different playgrounds such as Bedrock or ChatGPTs, you will most likely encounter that you can just ask it to refine responses by saying, can you build upon my response and just tweak this parameter? So those are some sample kinds of ways of doing it manually. But on the other hand, if you want to automate it more on the AWS side, we can start having certain steps to check these kinds of things. So that's, for example, why we have code build in place to ensure that the code is running properly. And that's why we have Lambda functions to appropriately respond based on if there's any error signals detected or if there's any template changes. So being able to respond to it autonomously is a very important thing. And ensure you write robust test cases. I feel this is something that a lot of organizations still don't take enough account on. It is very, very important, especially when you're looking into automating your workloads with AI, to be able to write these kinds of test cases to catch different errors that may occur during the pipeline. Because at first glance, sometimes scripts might look good, but there's always that factor of it might not perform as you require it to, or there might be a small error, which oftentimes these foundational models still make. So this is something that you need to consider while you look into automating your workloads with generative AI. And I'd like to just briefly touch upon a case study of my own too. So I've put this kind of seeding engine into practice with one of my recent projects, which is trying to build a rapidly growing website needing scalable digital infrastructure. As you know, when a website grows and when you start to plan for further enhancement towards it, you start to need to plan more on what services you need to use as part of that, what capabilities you need. And the goal essentially is just being able to get a dynamic scalable infrastructure for fluctuating demands with maintained security. So as part of the implementation, I then started to look at how I can do this. And that's when I also set up the seeding engine to see how can I start automating my workflows a bit more. So we use the seeding engine for initial infrastructure setup in this case scenario. I then started looking into how I can do adaptive scaling. And in this case, it refers to real-time adjustments for traffic and form submission data, because I want the traffic that goes through to still be scalable accordingly based on what has already been done within the website. And being able to check these kinds of templates with the automation that is being done within AWS, for example, is a really great thing. So I then also want to look into how compliance and security protocols are being maintained. And this can then be added as another step too within the generative AI workloads that we're trying to automate. So what was the result of using a seeding engine in this case scenario? The website was able to experience a significant reduction in downtime maintenance costs because, well, automation was able to be done on a higher level, and infrastructure was able to effortlessly scale to meet demand too, enhancing user experience and supporting growth because, well, we can pretty much focus more on the strategy side of things and less on the manual coding. So instead of trying to meet deadlines with a fast pace because we're trying to code everything up, we can instead say, let's have you code it up first, an initial version, and I can build upon it. So that really creates a lot of space for you to be able to plan the strategic objectives that you need and focus on the big picture that is currently needing to be addressed. So what are some key learnings? Firstly, the impact of automation cannot be understated. It is a very important thing that we have seen from this case study, for instance. So there's a lot of potential cost savings and time savings that can be gained from this. And DevOps is evolving. It's evolving in a direction of how generative AI evolves because more and more people are starting to look into how they can do this as part of their organizations and implement practices which can save them time and improve their productivity and efficiency. So it's certainly something that will continue fostering towards the future. You can enhance user experience without them noticing through these kinds of approaches. You'll also be able to, as I mentioned before, reduce costs appropriately because you're firstly reducing the time you need to tackle these kinds of challenges. And you also get some insights too if you ask the generative AI for recommendations, for instance. And it can't be stressed enough too, but security is key. So being able to have a second layer of checking with generative AI is a very important thing. I say second layer because I do still think that for security, the human aspect is very important. I'm not saying that any other parts of this automation process is not as important, but security is definitely one of the most important processes that require humans still within the loop. You need to ensure that the secure recommendations that are provided to you are valid and are not based on outdated measures. So you need to review what kind of recommendations are being proposed and appropriately incorporate them into your seeding engines. So what does the future of DevOps look like with generative AI? There's definitely going to be more of a cause for autonomous DevOps because as we've seen here, there's a lot of potential for that. There's going to be a lot more look into predictive analytics because generative AI is able to generate a lot of analysis and insights based on data that you provided. So there's definitely going to be a lot more look into this. You can look more into enhanced security with generative AI since you can get best practices and you can also train it on your own data so that it can recommend things based on your own guidelines too. I see towards the future that collaborative AI is going to continue becoming more of a bigger thing because at the end of the day, AI will not replace humans. We will simply need to gain a skill set towards working with them instead. And that's where collaborative AI comes in. We'll start working more with AI to be able to do what we need to do and monitor what they're doing so that we ensure that the final outcome of what they have outputted is per our requirements and not something that is hallucinated, for example, or not something that is part of our requirements. Finally, resource optimization will be a very big thing within the future of DevOps because being able to use generative AI for these kinds of use cases is very much in line with being able to conserve resources because they can also check how we are doing with our resources and accordingly suggest improvements too. So there's going to be much more of a demand for this towards the future, and it's certainly something I look forward to seeing more too. So what are some key takeaways? Understanding generative AI and creating your own seeding engine is an imperative aspect. You need to ensure that you understand what you're doing, what technologies you're currently tackling, and how it can best benefit you. Autonomy can be achieved with collaborative AI. So I would like to just raise upon the point again that when you look into these kinds of autonomous workloads, it doesn't mean that you are taking your hands off everything. You will still need to ensure that what you do will still be human monitored and human supervised because you need to make sure that the product you put forward is something that is the work of both human and AI. We have seen too many times the hallucinations that is possible and the unmitigated security risks that have occurred based on people's unmonitored and unsupervised use of generative AI. So it's very important to still have that human in the loop. And finally, don't cut corners. Ensure that the whole process, including security, is there because security is a very important aspect. Same as everything else. So don't just leave it to AI, but ensure that you have everything in a normal guidelines that you would have normally in place and ensure that you follow that accordingly. So that is all for me. Thank you so much for listening to my session. I hope that this has been of use to you and that you have gained some new tools to use as part of your toolkit in your day-to-day DevOps journey. And feel free to connect with me on my socials. I'm happy to answer any questions after this session. So again, thank you, and I hope you enjoy the rest of 90 Days at DevOps.